All right, so today we're going to look at combining like terms. And before we could talk about combining these things, we need to know what a term is. So we have a couple different types of terms. We have constants, and all these constants are numbers. All right, so like 3, -4, 1001, whatever, they're just regular numbers. They can be both positive and negative, and usually don't have 0 in there, but 0 is also a constant. Then we have variables. Variables, these are your letters. Okay, so Y, X, A, B, C, that sort of thing. A term, however, a term is a combination of constants, variables, or both. So you can have one thing, the other thing, or both that are together by multiplication. Okay, so addition and subtraction is what separates terms from each other. All right. When we're talking coefficient, usually we leave off the numerical, but it's a numerical coefficient. This is the number in front of the variable. Okay. And sometimes you see it, sometimes you don't. So as an example, if I have 3y, then 3 is my coefficient. If I have just y, right, you don't see a coefficient in front of there, and we always assume that coefficient to be equal to 1. We just don't write it. The same way with exponents, like y has an exponent of 1, but we don't write that. We also don't write numerical coefficients that are 1. Though if you do write it in your work, I'm okay with that, especially as while we're learning this. Right? So like terms have to have the same variable or variables and the same exponents. They do not need the same coefficients. Okay? So coefficients can be different. And we don't care about that. So when we're doing adding and subtracting of these like terms, we are really working with their coefficients. So examples of like terms, let's say we have 3 and 7. Okay, these are both numbers. All right, so therefore they are constant terms. And I can actually go ahead and add them. So if I have 3 plus 7, I'm going to get 10. Another way to express this as a like term, if I had 3x plus 7x. Okay, now I'm not looking at the coefficients, the numerical coefficients. I'm looking at the variable, and I want to check these two things. Do they have the same variable? Yes, they both have x. Is that x taken to the same exponent? Yes, neither one of them have an exponent, so they have an exponent of 1. These are like terms, and I would add them the exact same way I added 3 plus 7. So 3 plus 7 is 10, only because they're both x, I'm going to put x. Okay. Think of these as I have 3 apples, with x representing apples, and I have 7 more apples, and in the end I have 10 more apples. All right. Let's go ahead and do a quick example right here. So I have y plus 7y squared plus 3y. Right? Oh, I'm looking for like terms. Now all of these have y's. Okay? So all of them meet criteria number 1. They have a y. But only 2 of them have the same exponent, which is this one and this one. The 7y squared has a different exponent. Therefore, he cannot be combined or added with either of the other two. So the 7y squared doesn't get combined with anybody. Now the y, remember, has a numerical coefficient of 1. So I'm really adding 1 plus 3 here. That's going to give me a 4, but they're y's, so that's going to be y. They're both positive, so we're going to have a plus in between. And I'm done. All right. While we're going ahead and working with like terms, we need to look at some different properties of equations, and these are really important. I like to test on them. So the associative property, what it allows me to do by itself is change the order. Okay, and this works for addition as well as multiplication. And I'll show you a couple examples of each one. So if I have a plus b, that will be equal to b plus a. If I have a minus b, however, that's not going to work unless I keep the sign with the b. So you don't want to do it for subtraction, because it would not be the same thing as b minus a. Those are two completely different things. This one is no good. So only addition. For multiplication, if I have a times b, that's equal to b times a. Remember, 3 times 4 is the same as 4 times 3. Okay, same idea. The commutative property, whether the associative property changed the order. The commutative property just changes the grouping. Okay, but it does not by itself change the order. Okay. This also works for addition and multiplication. All right. Looking at an addition example, if I have a plus b plus c and have parentheses around a plus b, that will give me the same value as if I have a plus b plus c and group b plus c together, working that idea first. For multiplication, if I have ab times c, would be the same thing as taking a and multiplying it by b times c in parentheses. Okay, so where commutative property just strictly changes the way things grouped, notice I didn't change the order of my variables. The associative property just changes the order. There's no grouping involved with it. All right, let's look at the distributive property. So the distributive property, okay, most of you are familiar with this. You get taught this very early on and you use it a lot. What happens if I have a being multiplied by b plus c, where b plus c are not like terms? Because if they were like terms, I would use order of operations. This allows me to go ahead and multiply a times b and add it to a times c. This one also does work for subtraction inside there. So if I have a times b minus c, then I would have a times b for the front distribution, and then I would have minus a times c. Right? Let's go ahead and look at a few examples here. We're going to go ahead and work for them. So first thing I want to do is I want to look for like terms because I have variables. Here I have a 7x and an x. So remember, there's a 1 coefficient in front of the x. The 12 cannot be combined with anything else. So I have 7x plus 1x, that gives me 8x. The minus stays and minus 12, and I am completed. The next example here, for some of you, it may be easier to apply one of our properties, particularly the commutative property, because sometimes it's easier as they get longer to go ahead and switch the order. And I would like to switch those two so my y's are together and my numbers are together. So if I were to go ahead and write this, I'd have 3y minus 6y, make sure the signs stay with it, plus 3 minus 2. And now everything is nice and close together. I have my y's in one place, I have my numbers in one place, and all I have to do is go ahead and either add or subtract. So 3 minus 6y will give me negative 3y. And 3 minus 2 gives me a 1, so a plus 1. And I am done. This last one's a little bit longer. I do encourage you to try it before you go ahead and watch me do it. I'm going to show you a little different way rather than rewriting the whole problem to go ahead and deal with this one. So what I'm going to do first is the first thing I run across is a 7x. I go ahead and underline it or make some sort of marking, and then I look for anything that has x to the first power or just an x, and I have my 4x here. Now this is a plus 4x, so I consider it positive. So I have 7x plus 4x, that gives me 11x. And what I do once I have found the two I went ahead and put together, I cross them out. Then I'm going ahead, okay, well I have a negative 16 or minus 16, and then I have a plus 12 here, and I don't see any other numbers. So negative 16 plus 12 is a minus 4. And I'm going to go ahead and cancel those out when I'm done. Last but not least, I have, I'm trying to get another color here, sorry. No, I don't want that one. Okay. I have a 2y and a minus 8y. Okay, so the negative stays because the 8 is bigger. And 8 minus 2 gives me 6, and they're y's. And notice I really didn't concern myself with the order of them. At this point, the order does not matter. And I am done. I have done everything I asked you. Now, if I had any left over after I crossed out, then I would add that or subtract that to whatever else it went with. Also, it goes ahead and it works for multiplication. Okay, so here I have multiplication, and I have 6 times 9y. Sometimes you'll see people group them together in this fashion, where I have 6 times 9, and then the y on the outside. This is a version of the associative property. 6 times 9 is 54. And the y gets tagged onto it. It's multiplied by y. 5y times 7y, again, you might see some people grouping them together or just changing the order because it is all multiplication. So I could either switch the y and the 7 and drop all the grouping symbols, or I could go ahead and think of it as, I know I have 5 times 7. Those are being multiplied together, and then I have a y times y. So I kind of changed the grouping at the same time I switched the order. Both of those are often used at the same time. So I have 5 times 7, which is 35. And I have y times y, which is equal to y squared. There are 2 of them being multiplied together. We got to remember our rules for exponents. Okay, so when we add and subtract, the variable doesn't change, but when we multiply, that variable starts to change. The next one down, I'm not going to do any regrouping. I have a negative times a positive. We know that that's a negative. I figure out my signs first so I don't mess it up. 2 times 3 is 6, and the y adds on to that, or is multiplied by that. Negative on the outside of 8x, remember any negative on the outside with no sign in between, nothing else there, is a minus 1. And that is just going to go ahead and change your sign for each one of these. Okay, so I have negative 8x. All right. So using the distributive property, remember we had the distributive property if I have a times b plus c or minus c, I end up with AB plus AC. So we're going to go ahead and look at that idea. So first thing I want to look is do I have anything in parentheses I could combine? No. And I take my 6, multiply it by my x, and get 6x. And I have a positive 6 on the outside, a minus 3 or a negative 3 on the inside, which means it's going to be minus 18, and I am done. These are not, I can't do anything with those. So if you have terms inside the parentheses that can't be combined, once you distribute, you still can't combine them. This one we have a negative 3 on the outside. We want to take the negative with the 3. It's going to be a lot easier for us. So I'm going to think of this as negative 3 times a positive y. That's going to give me a negative, and 3 times y is 3y. I also want to take that negative, multiply it by my positive 7 or my plus 7. A negative and a positive give me a minus or a negative, and 7 times 3 is 21. Okay, so I've mentioned this a couple times of when do I want to use PEMDAS and when do I want to use the distributive property. Okay, first we want to go ahead and look at our parentheses. Regardless, order of operations will guide you to the right direction. X plus 7 cannot be added together because these two things are not like terms. The 7 has no variable. So this is a distribution property problem. So I want to multiply 2 times x to give me 2x, and 2 times 7, which is 14, and I am done. Now the second one here, notice I have 7 minus 2. I can actually do that operation. I would rather go ahead and do that than use a distributive property. However, if you do use the distributive property properly, it will still work out, and I'll show you both ways. So 7 minus 2 is 5. And there's a 5 on the outside. 5 times 5 is 25. Let's do it with the distributive property, see if we get the same answer. So we have 5 times 7, which is 35. A positive and a negative or minus is minus. 5 times 2 is 10. 35 minus 10 is still 25. So no matter which method you use, you should get the same answer. However, sometimes using the distributive property when you don't need to will cause your numbers to get really big. Couple more examples here. So I have a negative 3 being multiplied by 6x minus 2. 6x minus 2 cannot be combined, so I go ahead and distribute. And I have negative 18x, and a negative, this is going to be a sign change. It's going to be positive. Okay, so remember my tic-tac-toe board, right? A negative and a negative give me a positive. Okay, so remember how this works, 3 in a row. 3 times 2 is 6, and I am done. Could you have 6 minus 18x? Yes, you can. It's no different. Last example here, remember that minus sign is like a negative 1. This just changes the sign of everything that's inside the parentheses. So it's just negative x minus 3. The big thing is because it changes the sign, the ones that get forgotten, the first one usually happens, and anything after that, if it's more than one thing, generally gets forgotten. So I hope this made a little bit of sense here. We will be working on this. Ask me any questions, and I will see you in the next video.